to destination, we need to access the channel and we need to build some protocols. Okay, so these protocols, how it has been done, so depending upon the data rates or depending upon the loss of packets over the network, so based upon that we have defined or we have created some protocols. So the working principle of those protocols you need to study. So in this module number 2, that is what you are going to study. That is nothing but the MAC, that is medium access control. So in this medium access control, so as the name suggests, you can see and carefully read the statement, that is nothing but medium access control. So who is having the authority to access the channel? So that is nothing but medium access control. So once you have a control or once you have access to the channel, how you can control the channel so that you can successfully transmit your data from source to destination plays an important role. So that is why the name is called as a medium access control. So in this medium access control, there are different methods of how you access the channel. So the first method we are going to call it as a random access channel. Okay, so in random access channel, what we do is whenever the source wants to transmit the data, it randomly access the channel. So what do you mean by accessing the channel? It checks the channel, whether the channel is free or not, whether I can able to transmit the channel. So that is nothing but accessing the channel. So in random access channel, what it does is the source, whenever it has the data, it will directly transmit the data over the channel. So that is, we call it as a random access. So the moment I get the data, I will randomly access and randomly I will use the channel, I will transmit my data. So that is nothing but your random access. So in the random access channel, we have some protocols. You can see here, Aloha protocol. So the Aloha protocol, it has been again subdivided into two protocol. One is called as a pure Aloha protocol and one more we are going to call it as a slotted Aloha protocol. So we will be seeing in details what you mean by Aloha protocol and slotted Aloha protocols in details in the subsequent sections. The one more random access channel what we are going to study is nothing but CSMA. So CSMA is nothing but carrier sense multiple access. Once again, I am telling you, CSMA is nothing but carrier sense multiple access. So how if 3 or 4 members simultaneously wants to transmit the data, how it is possible? So then who is get authority to transmit the channel? So that is nothing but your carrier sense multiple access. You can see here, carrier sense means you are accessing the channel, you are sensing the channel. Multiple access, so multiple means multiple people are there to access the channel. So among them, how you give a priority and how you give authority to access the channel for the transmitter or the receiver to receive the data and to transmit the data over the channel, that is nothing but your CSMA. So in CSMA, once I get to know how I can access the channel when we have a 3 to 4 members simultaneously transmitting the data, then what I should do is what are the preliminary or what are the precautions I should take it, whether any loss will happen in this method. So yes, there will be loss happens when simultaneously data transmit happens over the channel. So in order to avoid or in order to detect whether the error has been occurred in the channel or not, so we have come up with a one more protocol. We are going to call it as CSMA-CD. So CSMA-CD is nothing but carrier sense multiple access the collision detection. CSMA-CD is nothing but carrier sense multiple access collision detection. So what this protocol it does is, so if there is any collidal of data from one sender to another sender will happen over the channel, means then it will be notified to the sender that the data whatever we have transmitted, it has been affected or it has been lost over the channel. So that is nothing but CSMA-CD. There is one more method we have, that is CSMA-CA. So what do you mean by CSMA-CA is nothing but carrier sense multiple access collision avoidance. So here in the first case what we have done is we have collision detection we have done. So means what, collidal is happened and we get to know that the sender, okay, my whatever my data I have transmitted, it has been lost. But how to avoid the collision? So that is the next step. So in order to avoid the collision, we have come up with one more protocol, that is nothing but CSMA-CA. That is nothing but carrier sense multiple access with collision avoidance. So these are the protocols which will be used in random access category, and along with this random access category there is one more category is there in medium access control mechanism, that we are going to call it as a controlled access. So in controlled access, we have a reservation, polling, and token passing. So these are the access method where we have some control in accessing the channel for the transmitter. So directly whenever the sender is having the data, will not get a chance to access the channel. So we have some built protocols and we have framed some rules and regulations before accessing the channel. So that is why it is called as a controlled access. So in controlled access, as I told you, there are three important protocols you are going to study. One is called as a reservation, polling, and token passing. So after that, we go for a wired LAN. So what do you mean by wired LAN? Wired LAN, it is also called as a Ethernet. Not internet, it is called as a Ethernet. So what is the IEEE standard for Ethernet and how it has been evolved? What are the characteristics of this Ethernet? How you can create a Ethernet? What are the addressing characteristics of this Ethernet? And how you measure that Ethernet, whatever you have built, it is efficient or not? So what are the parameters you are going to consider for measuring the efficiency of this Ethernet? Okay, and is there any different types of Ethernets are available? Yes, there are different types of Ethernets are available. That is nothing but access method Ethernet, physical layer Ethernet, and we have a gigabit Ethernet. Okay, so how these nomenclature or how these different mechanisms or protocols has been done, what are the main features and what are the users will be given for the user. So all those details you will be studying in this wired LAN. Okay, so these are all about our overview of your module number 2. Okay, so the second what I think is medium access control, that is nothing but multiple access. See, if you remember, when we studying about a data link layer, I told you, as I told you, there are two sub layers are there. So these two sub layers are responsible for getting the data from the network layer and transmitting the data over the physical layer. So in the physical layer, there are two links will be created. So I told you one is called as a broadcast link and one more is called as a unicast link. So in broadcast link, there are two types are there. One is a multi-point link and one more is called as a broadcast link. Okay. In case of point-to-point communication, there is no necessity for you to study about a MAC layer. Why? Because in point-to-point communication, the link has been already established and you have a transmitter and you have a sender. So therefore, there is no necessity for you to access the channel because there is a dedicated channel is already available from the transmitter to source. So therefore, when you have a data, what you can do is simultaneously you can transmit the data. Okay, so means what? In point-to-point communication, if the transmitting node and the sender node, if they are connected with a point-to-point link, means there is no necessity for you to study the MAC layer. But if you have a multi-point link or if you have a broadcast link from one node to another node, then there comes the functionality or there comes the importance of the MAC layer. So this MAC layer, it is responsible for you to access the channel in multi-point link or in the broadcast link. Okay, so therefore when you want to access the channel or when several members or several nodes wants to transmit over the single channel, means then you should give some priorities or you should frame some rules and regulations such that at any instant of time only one sender will transmit, or you can give a multiple access over the channel, but you should make sure that the data will not be lost over the channel when you transmit from the multiple transmitter. Okay, so that is what you are going to study in the MAC layer, that is nothing but medium access control layer. So you can see here multiple access protocols, it has been divided into three categories. So what are the categories is, one is called as a random access protocols and one more is called as a controlled access protocol and one more we are going to call it as a channelization protocol. Okay, so in random access protocol, what we do is we will be studying Aloha protocol, CSMA protocol, CSMA-CD protocol, CSMA-CA protocol. Whereas in case of controlled access protocol, you are going to study about three important protocol: reservation, polling, token passing. Is it over?
Yes, sir. Yes, sir.
Okay. Okay. Now, okay. So as I told you, in random access or in contention methods, see, we are going to call it as a contention method. So why it is called as a contention method is that, see, whenever we want to transmit the channel, so first we should access the channel, so that if we get an access priority or if you get an accessing capability, then only we can able to transmit the channel. So means what, we should fight with other senders, so that I can get a accessibility to the channel, so that I can transmit the data. So means what we are going to do is, so when I want to transmit the data, I should contend for the channel with others. Okay, so how I should contend? So before prior the others members transmit the channel data, I should transmit the channel. So or else what we can do is, so we should go for some mechanisms. In those mechanisms we can see that, okay, this is the priority what we should give for the user. So based upon the priority or based upon some rules and regulations, we should give access to the transmitter at any instant of time. So therefore this random access mechanism, it is also called as a contention mechanism. So means what, I should fight with some other, I should fight with the other users who has want to transmit the data. They are also having want to transmit the data among them. So who is going to win in that race? So for them only the data will be allowed to transmit over the channel. So therefore the random access mechanism, it is also called as an contention mechanism to transmit the channel. Okay, so the next thing is, so the next one what we are going to call it as, just wait a minute. So the next one what, so we will take about one by one now. Okay, so you can see here in random access method, each station has a right to the medium without being controlled by any other station. Okay, so as I told you in random access, so whenever you have a data, so you have a rights to access the medium without any provision with the others. Okay, so however what happens is, so if more than one station tries to transmit, so one station means here the sender we are talking about. So if more than one station tries to send means, so there will be an access conflict, or that is there will be a collision will takes place. So because of the collision, so whatever the frame you are going to transmit, so those frames will be destroyed or it will be modified. Okay, so therefore in random access mechanism, so what you have to do is, in order to avoid the collision, so you should make some procedures, or you should make some protocols for each station, so that you can avoid this collision. Okay, so how you should avoid the collision is, so you should frame some rules and regulations. So when the data is being affected by the collision, and when the users are transmitting the data, so you should make some list of questions and list of questions for how you can provide a solution for this list of questions you need to understand. Okay, so what are the possible collisions that will arise in order to study the collision between the frames between the data transmission? So these are the possible conflicting questions will arises when you want to transmit the data. Okay, so the first one is, so what is the first one is, when can station access the medium? So that is the first and foremost questions, so that will come into a mind. Okay, so when I should access the medium, okay, is there any priority, or is there any time within this time only I should access the channel before I transmit the channel? So I should see it, right, whether the channel is free or not. So if the channel is free means, then only I can transmit the data. So when I should access the channel, so I know that when I get the data from the network layer, so I should make it frame and I should transmit the channel. So that is what I have learned, but now it is not the case. So what I should do is, before transmitting this data over the channel, I should see who are all already transmitting the data. Okay, so who are all already transmitting the data, I should see. So when I should do that? So that is the first question will be coming for the transmitting node. So the next one, what can the station do if the medium is busy? Okay, now what I do, okay, I will sense the channel. So what, okay, I come to a conclusion that, okay, this is the means the medium is busy. So what I should do next? Okay. I have a data I want to transmit, but before transmitting the data, so okay, I have access the channel. Okay, no one is transmitting the channel. I get to know that. Okay, I will transmit it. If somebody is transmitting over the channel, means then what I should do? That is the transmitting node. What I should do? So that is the question you should have in mind when you want to access or when you want to frame the protocol in a random access method. So the next one is, how can the station determine the success or a failure of transmission? Okay, so how the transmitting node will get to know that whether my data has been transmitted over the channel successfully or not. Why? Because when you transmit the data, you don't have any control on the data. Okay, so if it is reached to the destination, okay, the destination will see the data. Okay, if you attach the CRC mechanism or if you attach the CRC frame for your data, means okay, by checking at the CRC whether the receiver can get to know that okay, you have transmitted the data successfully, or if the data has been affected by errors, means then it can transmit that acknowledgement. But the data has to reach to the receiver, right? So how the transmitting node will get to know that whether the data has been reached or not? So that also you need to see it. Next, what can the station do if there is an access conflict? So if if the collision happens between the two transmitting node, means so then what you should do it. Okay, so what you should do it, so that is where you need to understand. So when you want to frame a protocol in accessing method or in contention based mechanism of accessing the channel, so then you should follow or you should have an observation when you are building a protocol. So these are the things you should keep in mind and you should frame the protocol. Access the channel because it is free of cost. Okay, so therefore what we do is we are going to do the carrier sense multiple access will be happen. So why it is called as a multiple access? Because the node wants to transmit the data. So there are several nodes are there. It may be a several nodes wants to transmit the data simultaneously. So therefore we are going to call it as a carrier sense multiple access. Carrier sense multiple access. So for this carrier sense multiple access, we have two sub protocols. One is called as a carrier sense multiple access collision detection, and one more is called as a carrier sense multiple access collision avoidance. Okay, so how these two works, we will see it in the upcoming section. Okay, so the first one, what we are going to call it as a Aloha protocol. Okay, so what you mean by Aloha protocol is this is the one of the simplest protocols in random access method. It was designed in the University of Hawaii in the year 1970. Okay, so what you mean by Aloha protocol is, so whenever you have a data, so there are two versions of Aloha protocol is there. So in the two stages, this Aloha protocol it has been defined. One protocol we are going to call it as a pure Aloha protocol, and one more protocol we are going to call it as a slotted Aloha protocol. Okay, so what you mean by pure Aloha protocol is, see whenever I have a data, okay, so listen carefully. In pure Aloha protocol, what happens is, you can see here I have a 4 stations are there to transmit the data. See the names for the transmitting node or the names for the device, it may be changing depending upon the how we are using those devices in the data communication. Okay, so don't bother about, so in some cases you will say it is a node, some cases you will say it as a device, some cases you will say it as a station. Okay, so those are things are same only. So it may be node, it may be station, or it may be transmitting device, or it may be just a device. Okay, both are, everything is same only. Okay, so now we have, so you can see here we have a 4 stations are there, and these 4 stations simultaneous means these 4 stations wants to transmit the data. Okay, so when these 4 stations wants to transmit the data, what they will do is, so they will see the channel. They will see the channel and they will transmit the channel. So they will not bother about whether the someone is transmitting or not. Okay, so that protocol we are going to call it as a pure Aloha protocol. So in pure Aloha protocol, the moment I have a data, I will see the channel and I will transmit the channel. I will not bother about whether the channel is free or not. I will not bother it. Okay, so what I will do is I will sense the channel. At the moment I get the data, I will sense it and I will transmit the channel. Okay, so now you can see here, so there are stations are there, station 1, station 2, station 3 and station 4 are there, and these stations, they are transmitting at random instant of time. They are transmitting at random instant of time. So you can see here the station 1 is transmitted in one particular time. At that time, no other stations were transmitted. So now the station 1 simultaneously it is transmitting 2 packets. So at that time you can see the station 2 it is also transmitted, the station 3 it is also transmitted, the station 4 also transmitted. Now you can see here 4 packets simultaneously transmitting over the channel means what, the collision will happen, the collision will be happen. So during this time there is a possibility of collision. So and also you can see here there is one more case where you can have a collision is, so the station 2 and station 4 simultaneously transmitting the data at a particular instant of time. So in that instant of time there is a possibility of collision. Okay, so in pure Aloha protocol, so what are the advantages is, so this is a simple protocol what you can transmit the channel. So how it works is, whenever you have a data, you will transmit the data irrespective of other stations whether they are transmitting the data, you will not bother. Okay, so the moment you get the data from network layer, you frame it and you will transmit over the channel. So this is called as a pure Aloha protocol. So in pure Aloha protocol, there is a possibility of more number of collision will happen. So why? Because the other station doesn't know whether the other stations are transmitting the data or not. So the moment they get the data, they also start transmitting the data. So the duration over which 2 or 3 nodes simultaneously transmitting the data and they will overlap at each instant of time means then the collision will happen. So means you are going to lose the data. Okay, so in order to avoid this pure Aloha protocol, we have come up with a, so you can see it. So this is how the pure Aloha protocol will work. Okay, so you can see the station in a frame. It will, when you want to transmit the frame, it will send the frame and it will wait for the round trip time. So what we have told you, right? Round trip time. So it will wait for the 2 round trip time. Okay, if you get the acknowledgement means then it will go for the one more data. If it doesn't get the acknowledgement means then it will does is it will choose one random number. So means if doesn't get the data means it get to know that okay, the packet has been lost or it is taking more number of time. So it has to wait for certain amount of time, right? So what it does is it will create one random variable. So in that random variable it will generate some random number. So whatever the random number it will generate, it will wait for that instant amount of time. And again it will wait for some amount called as a TB amount. So that also you are not getting the data means, so it come to a conclusion that the data has been lost. So once again I need to transmit the data. Okay, so this is how your pure Aloha protocol will work. Okay, so you can see here. So we need, yes.
Sir, how to stop this collision, sir?
How this?
How will the collision stop? How can we stop the collision?
How can we start the collision is, now you can see Shreya. Okay, you transmit one signal, you are transmitting a signal. Okay, so what you are transmitting the signal at, let's say at 10 a.m. you are transmitting the signal. Okay, so and the destination what you are transmitting transmitting is, so let's say at 10:15 you are going to that frame, it will be reaching to the destination as 10:15. Okay, so means what? Means it has to propagate, right? So at 10:05 it will be in one place, at 10:10 it will be in some other 10 place, and at 10:15 it will be in some other zone. So like this the frame will be forwarding, or like this the frame will be transmitting. Okay, so at 10 a.m. I am near to the destination. Let's say I am near to the destination. At 10 a.m. also I also start transmitting the data. Okay, so now what, I am transmitting the data to the same destination to whom you are transmitting. Okay, so now what happens is 2 signals are propagatedly transmitting over the single channel. Okay, means not single channel, in the same direction. Okay, and they may collide and your data may be lost.
Okay, sir.
Understood? Okay, so the moment at a certain instant of time, your data will also come in same zone and my data will also come in same zone. So they will collide and there the data loss will happen. Is that clear? Is that clear, Shreya?
Yes, sir.
Okay. Okay. So therefore what we need to do is, so what is the vulnerable time? So the vulnerable time we need to measure. What do you mean by vulnerable time is the time duration which there is no any possibility of collision will takes place. So means what? The moment when a station transmit the data, so the other station, how much amount of time they should wait. So that time we are going to call it as a vulnerable time. So you can see here, so the TR is nothing but it is the time required for frame to transmit the data. So the moment when you want to transmit the data, no, it has require some time to make a frame and it has to want to transmit the data. That is nothing but T minus TR will be transmitting. Okay, so when frame A it has been transmitted, so it has to reach to frame C and it has to come back. Okay, so therefore what we should do is we should create a vulnerable time. So that time should define for other station that during that vulnerable time they should not transmit when some station is transmitting. Okay, so that station we are going to call it as a vulnerable time, or with that time we are going to call it as a vulnerable time. So the vulnerable time for your pure aloha protocol, it has to be 2F and 2TFR. Okay, so the vulnerable time for the pure aloha protocol will be 2 into TFR. So TFR is nothing but it is a time, it is a fixed frame length, it is taken in order to transmit from one point to another point. Why? Because when you transmit the data, it has to go to the receiver, and from the receiver you need to get acknowledgement, right? So therefore TR for the transmission, TR for the reception. So therefore the minimum time what the other station should keep quiet means before they want to transmit the data means it is nothing but 2 into TFR. So TFR is it is a time taken to transmit from one point to another point. So that is a vulnerable time for your pure aloha protocol. Okay, so therefore you can see here it is the pure aloha protocol vulnerable time is 2 into FTR. Okay, and we want to measure what is the throughput of this pure aloha